of the first chapter, and in this video we are going to be covering the classification systems. I hope you enjoy it, and let's get started. Alright, so in this subtopic, the first we need to learn about some key definitions. And the first key definition that we're going to be learning about is species. So what is species? It is a group of organisms that can reproduce to produce fertile offsprings. And what exactly does this mean is that these organisms, they have to produce fertile offsprings, which means that basically those offsprings also need to produce their offsprings. All right, so two organisms, they belong to the same species only if they can mate and if they can produce fertile offsprings. Now let me give you an example so that you can understand it better. For example, if a horse and a horse, they mate together, they produce a fertile foal. And by this foal, we mean that when this foal, it's going to become a horse. When it becomes an adult, it's going to be called as a horse. And when it mates with another horse, it can produce another fertile foal. So that means that this offspring right here, it was fertile. But similarly, if a horse and a donkey, they mate together, they produce an offspring that is known as a mule, and this mule is infertile, which means that if this mule mates with another horse or a donkey, it cannot produce any offsprings. So this mule is infertile. All right? So this was species. It's a very important definition, so you need to remember this for your exams, that it is a group of organisms that can reproduce to produce fertile offsprings. All right, moving ahead. All right, now the second key definition, which is binomial system. Now, students often find this quite confusing to understand, but it is very simple, so let's break it down. So, first of all, you need to know that it is an internationally agreed system of naming organisms. So, let's say scientists, they find something new, so now they have to name it. So in order to name it, the procedure that they follow, this is what we know, this is what we say that this is the binomial system. And in this, we call it as a scientific name. So any scientific name of an organism, it is basically made up of main two parts. All right, what are those parts? The first one is the genus, and the second part is the species. Now, as you can see, the first part is the genus and the second is going to be the species. So let's take an example over here. We commonly know this organism as a tiger, right? This is a tiger. But if you look at the scientific name of a tiger, it is known as Panthera tigris. I hope I'm pronouncing this correct. So in this, as you can see, the first part, which is the panthera, right? This is the panthera. This is the first part of the scientific name. So this is going to be referred to as the genus, whereas tigris is going to be referred to as the species. And notice how the genus, it is always going to start with a capital letter, and the species, it is going to start with a small letter. Important point. And also note that they are known, they're written in italic. All right. So the scientific name, it is made up. The first part is always going to be a genus, and the second one a species. Now let's try another example over here. As you can see, this is a banana, right? This is how we commonly know it. But the scientific name over here, it is made up of two parts. As you can see, this is the first part, which is musa, and the second one is paradiscum. So as you can see, musa is going to be the genus over here. All right, this is going to be the genus. So this is the genus, and then paradiscum is going to be the species. And notice how over here, again, all right. So notice how again the genus is written with a capital letter M and the species is written with a small letter. All right, and they're both written in italic. So questions can come up that identify which part is the genus or which part is the species, so you need to know this. All right, let's go ahead with another example over here. As you can see, this is a cat, and again, the scientific name of a cat is Felis catus. And as you can see over here, in this, Felis is going to be the genus over here. So Felis is the genus, whereas catus is the species. And again, because this is Felis is the genus, so it is it's going to start with a capital letter over here. All right, so F right here, it starts with a capital letter, and then because catus is a species, so it starts with a small letter. Are now, I hope that binomial system is clear to you all. Again, it is a system, so it is an internationally agreed system of naming organisms. So any scientific name that you're going to come up of any organism, the way scientists they name an organism scientifically, that is basically made up of two parts, where the first part is the genus and the second part is the species. All right, moving ahead. All right, now another very important concept which is known as dichotomous keys. And dichotomous keys, where this concept is not quite tested in your extended exam of IGCSE. I've seen it come up in your core exam more regularly, all right? So it comes in your core exam more often, but still, because it's a part of your exam, of course you need to learn it. So let's see what exactly dichotomous keys are. So we use the dichotomous keys to basically identify unknown organisms, all right? So we're going to see a lot of examples of how exactly dichotomous keys work and how do we identify unknown organisms. So again, you have multiple keys in each dichotomous key, and then each key is made up of a pair of contrasting choices. So you make up a choice and then you land up to your final answer, and then we say that okay, the organism is identified. But let's understand this by an example. All right, let's go. All right, so this is a very simple example over here. It's a very general example that I wanted to give you guys. Just obviously, questions like this are not going to come up on your exam. Very similar, but not like this. This is just a general example to show you guys exactly how dichotomous keys work. All right, let's get started. So as you can see, we have 4 organisms over here, A, B, C, D. Now, let's assume that we do not know what each of these are, all right? We don't know what they are. And these are some unknown organisms that have just come up, and we want to know that exactly, what are these? So we have this dichotomous key over here to identify each of them. Sorry. And as you can see, this dichotomous key over here, it is made up of 1, 2, and 3. So it is made up of a total of 3 keys. So first, let's look up at the first key. So when I look up at the first key, which is key 1A, it says that the organism moves from place to place. Now, obviously, we must be given some information about them. So I know that, yes, this C and D, these are the 2 organisms that move from place to place. So that means till now, I have the options as C and D. So I'm going to identify between C and D. And then, all right, so if they move from place to place, then I have a direction given over here that I need to go to key number 2. So let's go ahead to key number 2. It has wings. All right, let's see out of which C and D has wings. So I can see that C has wings over here. So yes, it has wings, so it is a butterfly. So that is how we identified the butterfly over here using a dichotomous key. And then 2B says that it has fins and it lives in water. So yes, it is a D. D is a fish because it has fins and it lives in water. So up till now, we have identified C, what is organism C, and what is D over here. All right, now this is all the information. This is how we identified C and D from the first key, part A. All right, now we're going to go to the first key, part B, which says that the organism, it does not move from place to place. All right, so that means that it can either be A or B, because these are two things that they cannot move from place to place. So now I'm left between A and B. Now I want it gives me the command to go to key number 3. So key number 3 says 3 key A. All right, 3A says that it has roots, stems, and leaves. Of course, it is this B one because it is a plant. All right, so we have identified that species B is a fern. All right, and then similarly 3B says that it has no roots, stems, or leaves, which is this right here. It has no roots, no stems, no leaves, no nothing. So it is a mushroom. So we have identified species A over here as well, which is a mushroom. I hope this is clear. Now we are going to move ahead towards an exam question. All right, that was just a general example. Now we're moving towards an exam question. So as I already told you guys, that this dichotomous keys are usually tested out in your theory paper, all right, theory core paper of IGCSE. And as you can see, this is a very recent paper. I extracted this question from March 2024. So let's see exactly what type of questions does the examiner love to test over here using dichotomous key. All right, let's get started. So again, this is a part of some question. So it's the part C of some question over here. And it says that plant species can be identified using a dichotomous key. And figure 2.2, which is over here, it shows that the leaves from 6 plant species A to F. All right, and let's see what the question is. So it says that use the key to identify the species shown in figure 2.2, all right, and write the letter of each species A to F in the correct box in the key. So as you can see, we have been given a total of 5 keys over here. So let's read the first key. So first key, part A, says that the leaf has a smooth, unlobed outline. All right, let's see which leaf has a smooth, unlobed outline. So I can see that leaf A has a smooth outline. It's not rough. Leaf B does not. Neither C, nor D, nor E, and F has a smooth outline over here, right? I hope you guys can see this. This is a smooth outline over here. Again, this is also a smooth outline. There are no rough edges, no nothing. All right, that means we have to identify between A and F. All right. So we are left with the I'm just going to write this down. This is not the final answer, okay? I'm just writing this down that we are identifying between the plant species A and F. Now it says that if it has a smooth unlobed outline, which is A and F, then I have to go to key number 2. All right, so I went to key number 2, and key number 2, part A, says that the leaf is more than twice as long as it's wide. So the leaf is more than twice as long as it is wide. All right, let's see. So let's compare the width and the length of these leaves. This is what it wants us to find over here. All right. Just a second. Let me erase this outline. All right. Now let's compare the width and the height. So let's say it's a rough estimate, of course. You don't need an exact scale or measurements. So let's say that this is the width of this leaf, X. All right. And then this over here, just a rough estimate over here, is X. And I can see over here that the width and the length of this leaf are roughly equal. So it's not that the length is twice as long as the width of this one. So it can be A. All right, now let's look at option F over here. Just a second. All right. Wait a second, guys. It is a bit stuck over here. All right, coming back. So as you can see, this, let's assume, I'm assuming this is the width of this leaf, which is X. All right. And now let me see the length of this leaf. There you go. So I can clearly see over here that, let's say if this is the width and this is the length L, then I can clearly see the length L is definitely twice as long as the width of this leaf over here. Again, if I can put 2x over here. So definitely then F has to be my option over here. That leaf is more than twice as long as it is wide. So I'll put my option over here. So I have identified that this is going to be F, and so the other one is going to be A. Why? Because it is not, the leaf is not more than twice as long as it is wide. So it is going to be this this plant species over here, and the other one is going to be this one. I hope it is clear. All right. Now, this is all the information that we got from this key part A. Now let's look at key part B. What does it say to us? All right, let's see. So leaf part, A part B says, key part, oh my god, key part B says that the leaf does not have a smooth unlobed outline. All right, let's see which one does not have a smooth unlobed outline. So these two have been identified, okay? A and F are done. So let me just circle this. This is done. I can see that B does not have a smooth outline. Similarly, C and D and E. So these are all my suspects over here. B, C, D, and E. All right, B. So let me just write it down as a rough thing for me to know. B, C, D, and E over here. All right. So these are all my suspects over here. And now it says that if they do not have a smooth unlobed outline, then I'm going to go to key number 3. So when I go to key number 3, it says that leaflets are present, and 3b says that leaflets are not present. Now, what exactly are leaflets? Well, leaflets are, let me just give you an example. If, let's suppose this is the midrib of the leaf, the center line that is passing through a leaf. And from that, if multiple leaves are coming out like small, tiny, like this, just like a fern. So I'm sorry, my drawing is a bit bad, but I hope you get the idea. So if small leaves are coming out of it like this, so these are going to be known as leaflets, small leaves. But if there's a big, giant one leaf like this, and like this, I don't know what happened. All right, like this, okay, just one giant leaf, then it is going to be a leaf. There are no leaflets present on it. All right, so let's see out of B, C, D, and E on which are leaflets present and on which are not. All right, so leaflets are present. So these are my suspects. What are my suspects? B, C, D, and E. And on which are leaflets present? Well, if you think that B has leaflets, now think clearly, all right? B does not have leaflet. As you can see, this is, this is too big. Wait a second. This is too big to write on it. All right, so if you think that leaf B has leaflets, now just these are not leaflets. This is just one big whole leaf right here. This is one whole big leaf. These are not leaflets. Leaflets would be that they're separated like this over here. Can you see? These are all, this is the midrib, all right? This is the midrib, the center line passing through any leaf. This is the midrib. And then you can see from this midrib, small leaves are coming out like this. Can you see these? these are called as leaflets. So B is not a leaflet. Similarly, C is also not a leaflet. And so I am left with the option D and E. All right, so D and E, they're both leaflets. So if leaflets are present, then I'm left with the option as D or E. All right, and I'm left with the option as D and E out of these 4 options. And if leaflets are not present, then of course I'm left with B and C. All right, I'm left with B and C. All right, now if leaflets are present, then I'm going to go to key number 4. Key number 4, part A, says that only 5 leaflets are present. So let's see which one has 5 leaflets, D or E. So this is D and this is E. I can clearly see over here that E has 5 leaflets present. Can you see that too? See, 1, 2, 3, 4, and 5. So there you go. I have identified what E is, and similarly, if 5 leaflets are not present, then it is going to be D over here. All right, let me just write that down. So if 5 leaflets are present, then it is going to be E. All right, so it is going to be E over here. And if more than 5 leaflets are going to be present, then it is going to be, wait a second. Sorry for the bad writing over here. And all right, so this is going to be D over here. I hope this is clear. So we have identified D and E as well. Now we're only left with B and C. So 3 key part B said that the leaflets are not present. So I'm going to go to part B. To key number 5. And key number 5A says, let me just tell you which ones we are identifying. We're identifying between B and C. All right, we are identifying between B and C. And B and C said that the leaf has spikes on its outer edge, and 5B says that the leaf does not have spikes on its outer edge. So which one has spikes over here? Let's see. So these are the 2 options that we're left with now, which is B and then C. So let's see which one has spikes. Well, again, these are spikes. Can you see this? These are definitely spikes, but these are not spikes. These are beautiful round edges. Can you see? These are not spikes. These are smooth lined edges. All right. So if it has spikes on its outer edge, then it is going to be C. All right. So here I'm going to write C over here. And if it does not have spikes on its outer edge, then it is going to be B over here. So now moving ahead towards the most important part of this lecture, which is classification and evolutionary relationships. Now, first of all, why do we even want the first question, all right, which is that why do we even want to classify living organisms? Well, obviously, to organize such a huge variety of living organisms, we have so many living organisms that have been discovered, and so to classify them, to organize them, we need some sort of a classification system, right? And the second thing that we want to classify living organisms is because we want to show the evolutionary relationships between an organism, all right? And we are going to go in much more detail about what exactly evolutionary relationships are, all right? And then, of course, to make it easier to identify an organism and allow scientists to communicate clearly across the world, classification of organisms is mostly done, and it is based on 3 main things, all right? Anatomy, morphology, DNA protein sequence similarities. So what is anatomy? Anatomy is a structure, all right? Morphology, the appearance of how something looks, these are the observable features. And then anatomy is more of like the skeletal structure and everything. You don't need to go in much detail of these, but just know that, classification is just based on these three things. Now, we see that earlier, back then when DNA and protein sequence similarities were not that similar, all right, scientists, they did not use this. Earlier systems, they used appearance only, which means they used anatomy and morphology more often to group organisms together. But now, the new modern classification, it is based on evolution. And what evolution means is that the organisms that are grouped together are more closely related because since they share a common ancestor, all right? So it means the modern classification, we say that it is based on evolution, which basically means that the organisms that have already been grouped together, it means that they had some link together. And what link did they have? They share a common ancestor in between. So if they're closely related, that means they share a very common ancestor recently. All right? So in modern classification, what we do right now, DNA and base sequences they are evidently used as a means of classification, and this is what we basically use in modern classification. Why? Because DNA contains genetic information, and so what scientists do is that they can compare the base sequence of the DNA. And what are the base sequences of DNA? A, T, C, G. So by comparing these four base pairs, four base sequences, they can easily identify whether organisms are closely related or whether they are distantly related. So let's say we find two organisms and they have very similar DNA sequences, all right? So if they have very similar DNA sequences, then we say that, oh, that means that they are definitely then closely related, all right? But if they have very different DNA, then it means that they're not closely related, they're distantly related. So let me give you an example of such organisms that have very similar DNA sequences. For example, humans and chimpanzees. Yes, humans and chimpanzees, we have very similar DNA sequences. And so it means that humans and chimpanzees, we are very closely related towards one another. And if we are very closely related, that means that we share an ancestor. That means that we have evolved recently from the same ancestor, and that is the reason why we have a more of a similar DNA. So that means we are more closely related. I hope you guys get the idea of what I'm trying to, make you guys understand. And then similarly, humans and insects, we have a DNA that is very different. So our DNA sequences, they're very different from one another, which means that we are distantly related. And another thing that means is that it means that we share a very distant ancestor. So this is the reason why we have very less similar DNA. So we are distantly related. All right, so what main 3 points that examiner wants you to identify from these from classification systems using DNA and base sequences is that it wants you to know that, all right, in modern classification, the first thing that we use is DNA and base pairings. The reason why we use this is because they're more accurate, they're more reliable, because they cannot change with the environment. But of course, appearance and skeletal things and everything, they can change with the environment. Environment has an effect on your appearance, right? But DNA does not. So it is a more accurate and a more reliable way of classifying species or classifying organisms based on DNA. All right. So if any organisms, so it means that if let's say this is, and let me just give you guys an example. If this is a species A and species B, and let's say this is just a very random example to make you guys understand. And let's say this is another species C and B. All right. So these are two groups of organisms that scientists have, let's suppose, divided. So in the first group, we have two species that are A and B, and in the other one, we have C and B. And let's say that these two species, now because they have been grouped in the same group, all right, because A and B are in the same group over here, so that means that they have the first point that I get is that, okay, they have been grouped in the same group. That means they have very similar DNA sequences. And if they have very similar DNA base sequences, then that means that they have evolved recently from the same ancestor. So their ancestor was very, it was a recent ancestor, not a very distant one. All right, so that's the reason why their DNA based sequences are very similar. But at the same time, if I want to compare A to B, and the same situation will apply for C and B as well, because they have been grouped in the same group, so they have very similar DNA base sequences, and that means that they have evolved recently from the same ancestor, and that is the reason why they have a more similar DNA. But if I want to compare A and C together, all right, if I want to compare organism A to organism C, and I want to see their evolutionary relationships, now by this through this classification, I can see what I can tell easily is that, all right, A and C, they're distantly related. Why? Because they've not been classified in the same groups, which means that they have very different DNA. And because they have very different DNA, that means that they're distantly related. Why they're distantly related? Because again, they share a distant ancestor. Their ancestor was distant. It was not a recent one. So that's the reason why they have very similar DNA and they're distantly related, just like humans and insects. Hope you guys enjoyed this video. If you guys did, make sure to follow up along this video series